Hey, mic check 1 2 3. Hello, hello, hello. Hey there, it's Jasa here. Welcome back with another video. So today we have an interesting topic to cover. None other than your favorite heap. So when it comes to heap, what is heap? So heap is a full tree data structure where it will store or represent it as an array, and we can get the left node and right node with some methods or with some calculations or something like that. So literally we have two kinds of heaps. So heapify up or not like that. So in heap we have two heaps, min heap and max heap. Min heap and max heap. Max heap. Okay, cool. Let me take this thing. Okay. So here we have two kinds of heaps. Okay. Now inside this there are something like we only need iteration and everything. So it's pretty simple. No need to worry about any of these things. So only we want to remember how to get the left node and the right node. Then do the logic as per the thing. So if you don't have any kind of idea about heap, please do refer something. Here it's the implementation part, where if you have any doubts, you can clear it out. Okay, cool. I will explain it along the way, but I prefer you have to check. Then you will get an idea about it. It's like watching a movie without starting at the middle, but you will get somehow somewhere, right? So okay, cool. Now let's try max heap. So max heap is a tree that we have, well, that will contain a maximum value. So let's say if it's have like this tree structure, why the space is not, yeah, and it will have what. So here what in this try is the top value needs to be greater than this. So the values I mean down to the top, it should be in decreasing order. I mean from downside it should be in the increasing order. Okay, cool. So it is basically used for prioritizing task and everything. So heaps are used for that. So let's see how can we implement these things. So class heap, max heap, max heap, and we need a constructor which have an array. This dot heap of array. So basically we will do heap inside array. So that's the thing. We can implement it. We cannot think. I think we can implement it using a tree structure, but basically generally we use heap, I mean array for that. So when it comes to heap data structure, one of the things that you have to be keep regularly in your mind is the how to get parents and children's and what else, right node, left child node and left right child node. So in order to get that, let's get parent. Get parent. Oh god, I forgot. Get, stupid. Then we will get the index. From here what we can do, so we can generally uh, what we can do. So in order to return, we have to return the parents index. So we can say it's kind of formula, so you will understand it along the way. So index, so let's wrap it inside a parenthesis index by 2 minus or plus 1, I think so. Index by 2 minus 1, I think so. Minus 1. Yeah, that's here. That sounds good. I think so. Yeah. I'm not sure about this, so let me just check it and I will come back. Okay, so it is totally wrong. Don't worry, I'm not going to teach you wrong things. So in order to get the parent value, I mean parent index, we need to minus the index and divide it by 2. That's all. That's pretty much all about that. Okay, cool. Now we want the right and left. Left. Get left node. We'll have the index for that. Oh, we cannot do. Can we do that? Something like this? Return. No. Return in order to get this in I or index into 2 plus 1. So in order to get something inside of right side, something that is in the right side, we can say right node plus 2. That's pretty much is cool, right? So all you have to do is just try to remember these values. Now, I mean, at the end, you will feel like, oh, it's pretty much, I mean, you will be get used to it. I mean, so you don't even have to remember it. Okay, cool. Now, what are the things we have? Insertion, right? Insert. We will have a value and we will push this dot heap. We will push that value into that what into that thing, into that heap array or heap array. So we will push that value into heap array and we will call heapify down, heapify up. I will explain it, don't worry. Okay, so heapify up this dot heapify up. Okay, cool. Now heapify up. So basically, when it comes to this heap, max heap, the array will be something like this: 10, 5, 3. Okay. Now here, if I insert something with the value of 18, it will, I mean, it will, what we can say, it will not be a heap. It will restrict the thing of heap, the property of heap. Now it's not a max heap, right? If I want to be a max heap, I need to be something like this. If it wants to be a max heap, it needs to be something like this. Oh, okay. So this is how it should work, but uh, I mean in the regular heap. So initially we are pushing it the value, whatever it is, it will push the value and we will call this. So this will ensure that the values are in a heap manner, are ordered in a heap manner, which means it satisfies all the heap properties or heap requirements. So in order to check that, what we have to do is we have to get that last node and we need to check the last node and its parent, and we need to swap it. That's all what we want, right? So let uh, index as in this dot get parent as in uh, oh, initially we need something like this dot heap odd length minus 1. Okay. Yeah, we can call instead of this, we can call something like this. Yeah, but let's make this standard parent index. So here we will have the parent index. Get parent, it will return something. And while we will check something inside the while loop. While index index is greater than 0. If it's greater than 0, I need to work till it. So I need to check or I need to compare the parent and its children. So as I mentioned before, it will be something like this: 50, 30, 1, 4. So if I push a new value, it needs to check at this and with his parent. So if this is greater than this, it needs to swap, right? So that's what we have, what we need to happen here, what we wanted to happen here. So if so parent is something that we always needed to get out, we can update it later, right? If this dot heap of parent is greater than, so if I mean if less than heap of index or children, whatever, we can say that I need to swap this thing. So we can swap. We have some easy ways. So this dot heap of parent and this dot heap of index. We can. It's pretty common, usual thing we used to see on the internet. So we can swap it some like this. I think no need of this extra array. Okay. Heap of and heap of parent. Okay, cool. So we uh, changed it. Else we need to break it, which means it will be in the sorted order and everything will work. So we need to break it. So it will swap. Then what we need, the parent index needs to be index and index needs to be in the parent, right? Parent and parent. Yeah, we only need to change the parent. Parent as a wait. Let me think. So if we change this to the here, we need to change the parent index or yeah, both child and parent. Think so. So here we can perform something like this. That's parent. Same parent index. Okay, cool. Now let's see if it's working or not. Yeah, we can insert these values. Okay, cool. Now let's see if it's working or not. Okay, now it's in the heap property. Now let's insert something. A big 16 or 80. Okay, it's not working. Why it's not working? It's not hippify up. Okay. Return. Do we have to return anything? No, I think so. I don't think so. We have to return. Other else, what are the things? I think there is nothing. Wait, let me check. Let me debug. So debug it will not waste your time. So what I have figured out is no need to change the parent index. I mean, we only need to change the index, and we need to get this thing from here. So index. So from we have an index, right? Yeah, this must should work. And also, it's not working. Let me check one more time. I'm too sleepy, but I want to finish this. Okay, so I got what the problem is. The problem was, what if it's have too much decimals? So we need to floor it. That was the problem. That was used to be the problem. So I think this is pretty much is about Heapify up. Now in terms of Heapify down, let's check it without any delay. Wait a minute. So let's move on to Heapify down, where we have to perform something while we deleting. So why we need to check that thing? So when we deleting, we only delete the first value. I mean the first value here, this thing. This is the value we are going to delete. So we need to check if it's properly aligned according to the heap property. So while deleting it, we will set this thing to here, and we will check accordingly. Yeah, now you will not get it, but after that, or pop, anything what you want, you can call it, you can name it. This dot heap of 0 as a pop, this dot heap dot pop. So yeah, now we have to call heapify down. So now we don't have any heapify down. Now if the heapify up was started from the end, heapify down is started from the first position. Okay, so we need something called index. Okay, buddy, index is in 0, and we need to take left or right, whatever. Left node assign this dot index. Okay, cool. And here in max heap we need the largest value, right? Let largest left dot node. Now we have to work it inside a loop. So while index less than this dot heap dot length, we need to get the right node also. Let right Get right node right. Let's call it right. That is better, right? And it will return the right node index, and if there is, if right is less than this dot heap dot length, and and if and what we have, uh, if heap of left, yeah, we need to change this as left. So actually what we are checking here is if left, in the sense we will get this, for initially we'll check which one is greater. So if left is greater than, yeah, initially left is in the largest. So if right is greater than left, we need to change the largest value. Heap, I mean our left, yeah, largest just in right. Okay, cool. No, no problems. Okay, now what we have to check is we want to swap it. So if, I mean, why am I writing if inside if? That's the thing. This dot heap of right, I mean largest or index, we can say index. Index is less than this dot heap of largest, it will swap. If it's that, it will swap. Heap of, oh my, why I am not getting, so auto suggestions. Heap of largest, and this dot heap of index, dot heap of index, this heap of largest, and we will change the index, index as in largest. So we will set that to largest value, and we will check from there. Okay, cool. And we will get the left value from here. So get left node in index. Else, if there is nothing, we can break this thing again. No need to work until this works. Okay, cool. Now this must should work. Now what we can say, if I delete this, this must should be in an order. Delete this and we will set this value. Yeah, cool. Now let's delete heap dot delete. Yeah, we only need to call this one. So let's hope it's work. Now the real time begins to debug. Yep, but there is a problem. Okay, what is the problem? It is not working as expected. And we are popping the heap and we are setting to the first index. So here let's console the heap dot log heap, this dot heap. Let's see what inside that. So yeah, it is not working as expected. I mean the 50th value need to become there, right? Insertion, after insertion 18. Okay, cool. And we will set while deleting we will set okay. So here yeah, cool. So here we will set this thing to here and we will delete this thing. So it will delete that thing and here it is okay, cool, working properly. And after that it is not sorting properly. I mean it is not heapifying down properly. That is the problem. Okay, now let's go through a debug session. This where it begins. It just needs to be something like this. No, just an assumption I thought. I mean, while index is less than right as in and right less than okay. That should work properly. I don't know why it's not working. I think no need of break. This needs to be work after. Should be so let me go through it deeply and I will let you know after complete. Okay, I think I have figured out the problem. See, these problems are just kind of missing things, so I need to invoke something here in order to work something, right? Ah, it, wow, it is an endless loop. So I think here we need a break case. Okay, perfect. So it was a misconception of these things. I mean, actually we need break or else it will be in an endless loop. So here we didn't invoke it. That was used to be the problem. So that's all about the heapify down. Now I mean heap max heap. Now let's move on. Now what if I say this is what I have to do in min heap? Yeah, the methods are same. Everything is same. What we need to change is just the arrow. Surprise, right? Yeah, like that. Only we needed. Happy. And we need to check this properly. And let's delete this to make this to smallest. Because okay, smallest just in left, and we will check if the right is greater than if the right is less than, and we will check if index is greater than. Check. Okay, perfect. Okay, hell, we're on max heap. Sorry about that. Node min heap. Yeah, this is not working properly. What's the matter? Let's debug through it. So initially this is coming here, and what about the other values? 6, where is 6? So there is some problem here. Let's check. Let me check the in insertion part. We don't have. I think we don't have any problem. Let's check one more time. Yeah, in insertion we don't have no problem. Let's check what is the problem inside deletion. So here we will check if right is less than length, that is needs to be checked, and if right is less than length, and if right is less than left, yeah, this will come here, and if index is greater than smallest, if index is greater than smallest, if index is greater than smallest, so this is yeah, now I think I believe this should work. Let me remove this comment. There also some problem here. It is properly not working as expected. Let me debug it. Okay. So literally I forgot to repost button. So very good. That is a good thing. So here there is some mistakes, minor mistakes in heap if I down when it comes to min heap. I believe that this is what we all needed to do, but there are some alternative ways. So I have written this. It is nothing like it was what we have done in the previous thing. It was like that. No need to worry about what happened. Okay. So this is pretty much it with the heap, min heap and max heap. So I would like to conclude, and I'm very burned out because of this. I have took two recordings in a straight line. So let me take first. So yeah, that's all. Thank you for listening. I hope it's understand. If you don't understand, please go search, study, watch other videos, then come to here and comment you understood. So thank you for listening and thank you for your patience.